G'day everyone and welcome back to the channel. So I've had this running for quite some time now. Like I said at the end of the last video, I put the 180 ohm resistor back, 680 on the bias, and it's slowly creeping up to 4 millivolts after about an hour. And the heatsink's like not even warm. So I then thought, well, you know how the current source, look, if I just take some heat away from this heatsink, the bias starts dropping. I thought, what if I add some cold to the reference LED? Oh, it goes the other way. So if I couple the two together, and I did some research into this because I wanted to know what the temperature coefficient was. Oh my God, not only the red LED is the lowest noise, but for a current source, it almost couples perfectly. So my bias string's working now. It's working perfect. This is the only thing that's running away, and if I couple it to that, it won't run away. So you know what I'm going to do? The LEDs are going to get coupled to the current sources. I wonder if there's any point in doing it to the input stage. I guess although it maintains a constant current, the thing that confuses me is it does that by adjusting the voltage, obviously. But if the voltage is constantly creeping up because of heat, wouldn't the current also? I think it is actually, because I measured the current sources cold and they seem to have like a milliamp or half a milliamp at least when they're hot. So I think, yeah, that's what I'm going to do. I'm going to couple the LEDs to the transistors. I might even change the LED type for this one to a miniature red LED, as long as it's got the same voltage drop and it's the same type of LED. And that way I can, you know, get a little, that's a large 1092F or P or whatever it's called. A little, what are they, 3.5 mil LED. That'll couple to that nicely. And then the larger one, I'll just sit in the heatsink. This is only lukewarm. It's nowhere near like, not a good temperature for the LED. But yeah, bias is fine. So that's great. So, I don't know what I'm saying the next episode. It is next episode. So I'm recording this on the same night. I just finished one episode. So, I'm going to get those coupled, but I'm not going to do that now. Because even as it is, the bias is basically fine. So now what we're going to do is try and work out where the hell this starting up and gain problem's coming from. The gain and the starting up's the same thing, obviously, because there's not enough gain or something's loading the input down when it first turns on, and one side tries to turn on harder than the other side tries to pull it down, but because of the gain restriction it can't, and you see why this is a problem. So that's what's happening. So like I said, I'm going to dig into this driver stage. I think the output stage is perfect, so it's got to be something here. So let's get into it. Alright, I just wanted to note this down for you guys too. I was thinking about it. If I couple diodes to the driver transistors, instead of just having them on the board, thermally couple them, like I'm going to couple the LEDs, everything in the entire thing will be thermally compensated. I've already decided to make bridges for the current mirror transistors so that they're thermally matched. And I'm going to do some research on the input pair too and see if they should be matched, like the two or all of them or whatever. Same with the current mirror, is it just the top two and the bottom two to get matched, or should all four go together? I'm going to do some research on that. And yeah, that's something else I'll do. It won't be hard because I can literally just bend them and they'll be touching, and I can just put some like contact adhesive, like some sort of thick gluggy glue that builds up a nice blob between them and squish them into it, so like one mass, you know. I can do that to, actually that might be a good way of getting the LED on the transistor. Yeah, true. Cool. So there you go. I've worked out where all the thermal problems are on the thing. So it's now 2:23 in the morning. When it was going up to 4 millivolts, it was around 1 o'clock, 12:55. It's only gone up that much in all that time, and that's literally, as I showed you, just this transistor slowly heating up. So I mean, once, yeah, I told you the bloody diode string works good on that heatsink. The diodes I've got, you know, I tried lots of different diodes when I was building this. Let me show you something. This will blow your mind. Where are they? I tried 3 different types of diodes, plus I tried taking one in 4007s. You'll see a whole lot in here. Some are glued into a string of 4. Some, I threw the single ones out because the leads were really short on them. I had them glued directly to the top of the transistors, different places on the heat sinks. That's where I started with this. Then I started with these different diodes, and then I landed on the BY229 because of the temperature coefficient it had was perfect. And then I experimented on different placing on the heatsink, and then I got what I got. That's how I designed this thing. It actually took quite a lot to get it to work perfectly. Like it's not a lie what they say online about diode bias spreaders that can be finicky and not the best performing and this and that. Oh yeah, that is totally true. There's an art to it, but if you can do it, it works just the same as a VB multiplier, if not better. I would wage that those like thermal track devices like the SAP15s and that would work better than a VB multiplier. Of course, because it's inbuilt in the package on the die. But heat rises and the convection that is really quick. So that's a really fast responding feedback loop. And with the right amount of current, which 8 milliamps, 6 to 7 milliamps going through that, I think it was. I can't remember. I can have a quick look. One day I'm going to do that in a really bad spot. The current going through the bias string, yeah, 6 milliamps, right? Much different to 10. That seems to be the sweet spot for it. Like I said, as you can see, it is tracking perfect. Like it's better than when I originally had this thing. I could get it to track, warm up within a few minutes and stabilize within half an hour. This is doing absolutely wonderful. I'm honestly shocked. Like the diodes are literally tracking perfectly now. I just need to sort this out. So I've got all my thermals answered. I'm a very happy man there. I've decided, yeah, I'm going to do the current source for the VAS transistor. I know that's not going to solve the problem. I've still got to solve this problem first. But I might do that first. I might do it afterwards. It's not going to make a difference whether it's there or not. It's not going to cause another problem, and it's not going to fix the problem, so it's not going to make a difference. If I put a current source there and set it for 8 milliamps, yeah, you know what I mean? So what I'm thinking about doing is basically where you got this resistor to the rail, that's where your current source would have to go, right? Now, I could take that resistor off and make a riser board that bonds onto the ground rail, the negative rail, and that pad that goes to the emitter, like one of these boards. All right, that'll give me my rail, my ground reference, and my output, which is all I need for the current source. And then everything can get built on that board with the transistor at the top with a heatsink going this way. The same one of those. It's a little riser board that just stands up there. It's literally going to have what? Couple of caps, LED, resistor, three resistors, one cap. Yeah, sorry, three resistors, one cap, one LED, and a transistor on the top. So it'll be a board that's probably about twice as wide as that. It'll overhang the board about that much. It'll go up to this transistor and come all the way out to here. Maybe not. I might be able to actually fit it. I reckon I could fit it. Maybe with just a little bit of overhang and maybe just a little bit higher than this one. Like that much higher. I reckon I can fit it in there. So I might do that tomorrow. I haven't made up my mind yet. But the thing is, I put so much effort into looking at the blameless amp and taking the piss out of it in my own words, laughing at, terrible common mode rejection on the input and this and that, and current sources being shared, and just things that I didn't agree with it. CFP output stage, all that sort of stuff. And I thought, well, I've addressed everything, literally, yet my fast transistor's going straight to the rail. I can't leave that like that, you know. It's like a half-assed job. I've done top and bottom here, top here, nothing on the bottom here that provides isolation from the rail. You know what I'm saying? The current mirror provides excellent rejection from the rail. The current source provides excellent rejection, so that's centered in between rejection and rejection. Everything here has got rejection on the top, but none on the bottom. So I got to do something about that. Yeah, I should have done it in the first place, but I did say that this is going to be a work in progress, you know, and as I go along, I'm going to work things out with it and, improve the design. Don't forget, after I get that done and get this game problem solved, I've still got all of this to look into and do. So, there's a lot coming. These boards will end up with, that add-on board, so another 2 add-on boards, and then possibly another 2 add-on boards for the rails if I decide to add regulation to the rails. I might not. I'm quite happy with passive RC filtering if I've got current sources everywhere and mirrors. So I'm actually thinking about just maybe upping the RC filtering a bit and adding the current source. So just one more standoff and that's it. That's the whole thing done. And in my mind, that is one high-end amp because, you've got a current source on top of a complementary feedback input with a 4 transistor current mirror at the bottom of it. You've got a beta enhanced transistor, VAS transistor with its own current source at the top, and then a buffered Darlington output. What more can you ask for? And then all the component choice. So, yeah. I'm going to be happy once I've done that. So that's probably what I'm going to do tomorrow. But I might just play around with it as is, seeing as it's pretty stable as it is now, and work out what's wrong with the gain first. But like I said, either way, it's not going to make a difference. And I'm not going to build it and into the case until I finished everything anyway, so it's all got to get done. The stuff on this list, the current source, the gain problem, it's all got to get done before I put it in the case, so it doesn't really matter in my mind what order I do it in. Obviously, I need to fix the problem that exists right now before I start doing all this stuff, but the current source, I don't know. I might do that tomorrow first and then get into the problem afterwards. The current source will actually add some more linearity to it too, because at the moment your top drive transistor and the bias string going down to this transistor has got a set current. Now the VAS transistor's got an undefined current that varies with its different conditions, thermals, voltage, load, and some of those things shouldn't be that way. So yeah, anyway, that's enough rambling on. I'm going to go get some sleep. Be back tomorrow. We'll pick up where I've left off. Let's see how much the bias has crept up quickly. I reckon it's probably about 6.5, maybe. 6.2. That's what I mean. It's very slow. The diodes are tracking. It's just that as it slowly warms up. Like I said, it will keep slowly warming up. Eventually, it won't keep warming up, but heat's got to travel down and into stuff, and everything else has got to come up to temperature. And once that's come up to temperature, and the only more cooling is what is actually actively getting off everything that's up to temperature, that will still keep slowly getting hotter. So that's, yeah, I've just explained how to deal with that. So see you all in the morning. All right. So I hope that was in view before. Just in case it wasn't, I'll show you again. 845. Right. 10 milliamps, 1 milliamp, 10 microamps, 1 milliamp, 10 milliamps. The 3200, right, double was good. Out of everything else I had, BC550s actually tested really good as well. It's about 45 at 10 milliamps. What's this? About 30. So it's a toss-up between 2SC 3200 and BC550. I've got 4 matched BC550s to go just in case I do choose them, but I haven't made up my mind just yet. But it's going to be one of the two. I have decided upon that. I'm thinking maybe, although the BC550's got a little bit more cob and it's got a slower FT than the 3200, I think it's probably still better to use it. Although, let me just look at one more thing. At 1 milliamp, the 3200 135, the 550 202. Yeah, they're pretty close. Once they get into the milliamp range, 10 milliamps, 550, 3200. .550 does have a lot more gain. God, this is a toss-up. I'm gonna do this off video, because otherwise I'm just gonna sit here going and you guys are gonna get the shits. So I'll be back when I've made my mind up. Something I forgot to add. The reason I'm putting the current source here, current sink, it's not just because this transistor, it's a two-part reason, right? People worry about this transistor and the one before it getting destroyed, but especially that one from too much current because its current's undefined. Okay. They have that solution for that, which is the current limiting transistor. So you take the base of a transistor off of the resistor that's there and set that transistor up as a current limiter, if that makes sense. Now, doing that adds another component in the actual audio chain, right? You don't get any benefits. It only causes problems, and it's just a band-aid to limit current. Well, why don't you just define the current in the first place? Because not only this eliminates the whole current limiting transistor that ties into the VAS transistor in a way that's not good, this offers great rejection from the negative rail, which is the major problem in the blameless amplifier. Well, the blameless amplifier's got plenty of problems: shared current sources, lack of proper current mirrors, blah, blah, blah. Anyway, I've solved all those problems, but there's still one thing in this amp that it's lacking, and that's good rejection from the negative rail with the VAS transistor. So this solves removal of the current limit transistor, and it gives you better rejection from the negative rail. And I'm not sure, I'm only speculating, but it may improve the gain and the performance of the VAS transistor as well. So I think that's, a win-win. But I just wanted to go over the theory and the workings of it. The whole philosophy, my whole philosophy for this build is add as much complexity to it as I can that benefits the design in terms of audio quality and all that sort of stuff, whilst keeping it as simple as I can in terms of not adding components to the audio path that don't add a benefit. So you'll see a lot of amps that have got like 2 input stages and an op amp in front of that, and tone controls and all this other crap. I'm against that. Maybe 5 or 6 stages, whatever, after the VAS. I don't like that, But adding an extra 2 transistors to the input pair to make a CFP pair, there's a benefit in that. Adding an extra 2 transistors, or even 2 to start with, or 3, or even better, 4 for the Wilson current mirror, massive improvement, right? The 2-pole output inclusive compensation, massive improvement. The beta enhanced transistor, that, taking load off of here, lowers the THD by a shit ton. The current source being separated from the other current source means that no matter what that tries to do to its reference, it doesn't affect the reference for this current source. So they're completely isolated from each other. The current sources provide good rejection from the top rail. The current source that I'm proposing to add here will add good rejection from the bottom rail. So you see how everything I've added here, there is a reason for it. I have not put, clipping diodes, capacitor, RC snubber networks on the input, just lots of extra stuff that you see in a lot of amps. I have admitted that stuff for a deliberate reason, that the current limiting transistor, anything that's in the signal path that's going to degrade the signal in some way, I don't want it there. Anything that can potentially improve it in some way, I want it there. So that's my design philosophy. So I just hope that everything makes a little bit more sense with that in mind. All right, it's the next morning. It's about, I don't know, 9 o'clock. What is the time? 9:16. Where to start? So I've changed the 2.2k resistors to 1.8k because bias was still a little bit high last night, remember? Now I know that's going to be lower with the heatsink warm, but the pot was already bottomed out. So now the pot will either be bottomed out or in the middle. It'll be closer to the middle than bottomed out. Yeah, no, it won't be bottomed out. It'll be in the middle. Anyway, now my minimum idle current is 4 millivolts. I can still turn it up with the pot, right? But it's nice and low. So now that's out the way with. I've done it on both channels. What I'm going to do now is I'm just going to quickly change those rail resistors. I don't know if I showed you guys the actual volt drop or not. I can't remember. I'll just show you quickly. 47 ohms got 300 millivolts. 10 ohms got 47. I'm going to make that about 100 and 150 millivolts respectively, so I'm going to change those resistors now. I'm going to need to grab some more resistors. It seems I didn't grab enough. Anyway, I'll get that done, and then as soon as that's done, the first thing I'm going to do is mount that LED onto the heatsink, and we'll see how stable the bias is. I might do both of these LEDs because I mean, the input stage, it doesn't have as great of an effect, but it will still have an effect on the bias. So, yeah, I'll do both of those. And anyway, one thing at a time. I'll get these resistors fitted. I've got to go get another two 22 ohm resistors. I'll be back when this is done and we'll continue. Alright, that's all the resistors installed for the power rails. I'll just give you guys a look at the voltage drop across them now. I haven't even looked myself. Bear in mind the resistors are going to the driver section. The voltage drop on that will increase as you turn... Oh crap. What? I have the worst luck anyone could have, I tell you. All I changed was the rail resistors. Literally. Nothing else. What the hell? No. Cannot turn it on. This is absolute madness. Let me short over the bias. I've even got the bias turned down. Try again. Yes. Cannot run bias now. What on earth? Oh my goodness. And yes, I've checked. The resistors are in the right spot. What? What? Hold up. Hold up. Okay, it's still a considerable drop for a 22 ohm resistor. What about my... Yeah, that's what I wanted to see, but what the hell? I'm just double checking that I put... This thing's going crazy. What the... Oh, Jesus. It's drawing like 2 amps of current. This is insanity. This is absolute insanity. All I did was lowered the resistance to the rails. Lowered it. I am literally losing my mind here. What? It's unstable as. I cannot get it to bias. Yeah, the other side's exactly the same. This is crazy. This is actually crazy. I don't know what to say. This is ridiculous. Absolutely ridiculous. Far out. Let me play around with this off camera and I'll see what I can find. Alright, so plot thickens. I thought maybe there was some sort of RC tank circuit with the resistant time constant, with the resistors and the capacitors and the leads going back to the power supply and all that sort of stuff. So I bypassed all the resistors, no difference. Starting to wonder, because it seems like it's a power rail thing, and it actually seems, well, the more resistance I've added, the better it is, the more stable it is, which tells me that it's really susceptible to what happens on the rails. Probably the negative rail, because the VAS goes straight to it. I'm starting to think maybe I should experiment with a VAS current source, even on breadboard, just to try it and see if that fixes the problem. Because the thing I keep doing is it keeps smoking these 68 ohm resistors, and yes, it's doing the same thing to both of them now. Both channels are the same. So, yeah, a bit of an issue. Alright, so I breadboarded the negative side current source. Hold on. Oh. Something's not right. Ah, God. I just can't win, can I? Something else is wrong now. We've got some sort of offset on the output, and the input's trying to compensate because that 2.2k resistor is getting hot. Oh, God. At least the current source is working. Yeah, right, that was up there. Yeah. Yep, at the rail. So adding a current sink, has completely screwed up this circuit. I can't win. I truly can't win. Let me again have a think and see why this might be. But anyway, that's what I've added, what I was talking about. I'm going to have a good think about this, steer at my circuit. I'll be back soon. Something that just occurred to me was, well, we've already got this stability issue. what does it do when it crashes? Is it doing the same thing? So let's isolate the current source. And let's have a look. I know there's no 68 ohm resistor in there. That's not going to affect nothing. Let's see. So I'm just going to start up normal. Right. Bugger all offset. Remove the bias and see what happens. Okay. So it is going positive. Okay. So I need to do it for longer, but I don't want to smoke anything. I'll just do it with the bias open. No, 39. Oh. It's like it's trying to fight itself. Like one side's turned on more than the other, but well, obviously to get that voltage. But I don't know what to make of that. And yes, the current source works perfectly. Current sync. I tested it out of circuit. 8 milliamps, like the top one. Yeah, no clue what's going on here. But I just thought I'd have a look. That does give me some faith that the current mirror hasn't caused a problem. It might have caused half a problem. I don't know. Like what I mean is if it's already going, say, like 39 volts, and with that it's going to the rail. I don't know if that's adding the other 20 volts of problem or if it's just accentuating the problem that's already there. But I've got a feeling it's accentuating the problem that's already there, and it's actually not a problem. What I might do is try lowering its resistance, because I know the bottom VAS transistor is used to having like undefined current, and its emitter resistors 68 ohms is usually pretty high for it. You know, I've seen it as low as 12 ohms. People usually use around 33 to 47 ohms, sometimes 22. So maybe if I turn the current source up a bit, current sync, to offer a lower dynamic impedance, you know, it'll still have better rejection and it will still have a defined current limit. I don't know. I have to do some thinking and some research before I do that anyway. Alright, I've been doing a little bit of playing around with this. I haven't done any research yet, but I've just been playing around with it and thinking about it. I've still got it set up the same at the moment. I just want to show you something. I've got a 10 ohm resistor in there at the moment. Even if I put a 33 ohm resistor in there, and we'll look at the offset. That's going to be an easiest spot to clip onto. Right there. Now, don't forget, even with the bias shorted, since I lowered the resistor values to the rail, it won't start up at all. But watch this. Now, if I try and open bias, I hope. But you see it lights up. and this offset, but then all of a sudden it dims out and the offset just goes, right? So if I put a 10 ohm resistor in there, the current set resistor, oh, let me just do that again. I had charge stored in it. Let me start up from 0. Not that it should act like that, but hold on. Right, I'm going to turn it on. See? Goes away a lot quicker, and the offset goes basically to where it normally is. Eventually. Or was that when I short the resistor? No, the resistor doesn't have an effect. So, oh crap. I hate that when I see it drawing an amp of current on the power supply. Everything's all good. So you may ask what happens. I tried setting this to the one. What is it? On the other side that I've got. Yeah, 180. I think it's 180. Yeah, 180. Alright, if I put this current source at the same setting, oddly enough, it's not drawing any excess current, it's just at the rail. And I swear when I did this before, it was at 30 volts, not the rail. Right, that 2.2k resistor's getting hot. I can smell it. It won't get anywhere near burning that quick, but I'm not gonna leave that going. So I'm not entirely confused yet. What I've been thinking is, at the moment I've set it up like this. So the fast transistors, your current source up here goes in the base of that transistor. Current comes out the base of this, goes in the VAS, in the collector of the current source, and down to the rail. What if, actually no, that won't work, hanging the VAS off the 0 volt rail, because it won't be able to swing. There has to be a way of doing this. There has to be. There has to be a way, and I've been researching it and I cannot find anything. I was thinking maybe if I do it with a PNP transistor. Is it even possible? I'd have to derive my reference from the opposite rail. Transistor would be around the other way. Why not just eat the signal in? Yeah, I've got a bit of thinking to do here, so I don't know that this is actually going to work, but it has shed light on something. When I lowered the resistance values, I couldn't get it to start up even with the bias turned off. I always suspected, because the VAS transistor goes straight to the rail, that it's a problem. And wouldn't you know, as soon as I got it off the rail via another transistor, it turns on again. Now it's not stable yet, but it made an improvement. And I would wager my money that if I put a current source here or anywhere else, it wouldn't start working. But the VAS transistor, yeah, it is. So I find that quite interesting. Anyway, I'm going to continue pondering, maybe try and set this up in a different way. Yeah, I'll be back shortly. So I've been doing some research. Well, not really research, but you know how with a lower resistance here, it'll actually start up now, where it wouldn't before. If we take a look at the Hummingbird amplifier, 47 ohm resistor, but the electrolytic and the 100 nano is at the current source for the input pair. Look what's right at the bottom of the VAS transistor. And remember when I decreased this value, we started having problems? So you know what? I then went on to read a few things people had to say about Doug Sells' VAS design. And apparently there's massive stability trouble with the VAS transistor running off the negative rail, and noise, current pulses in the rail, voltage dips completely mess with it. And it's really not good. I think it was Doug Self or someone suggests putting a 47 ohm resistor and then get this, a 470 microfarad capacitor to build an RC filter for that transistor. I'm not about that. So I might dig into my power rails and everything, because I've got a few rails split up and caps in different spots and different value caps and stuff. There's a possibility that there's sort of a tank circuit happening. What I'll do is I'll just bridge all the rails together. I did that before. Wait, what am I saying? I shorted over all the resistors. Yeah, no, it wasn't that. Yeah, no, adding resistance made it better. So it's not my power rail layout. Well, I'm going to continue working on this, but I'm not liking the VAS circuitry, because its top current is defined, but whatever it sources from the bottom is undefined, and if you try and define it, that creates too much of a dynamic impedance or resistance, whatever you want to think about it, and a volt drop from the rail until that impedance drops, and that stops it from being able to pull down hard enough. So it's kind of yeah, I got a bit of thinking to do. I want to solve the problem, not just band-aid it. So we'll see how I go. Alright, I'm going to end that video here. I've actually already done a lot more work, as you can probably tell. I had a look at the footage and it's getting really long, so I'm splitting it up into two videos. So I'm ending this half of the video now, and then we'll continue on with this in the next video. So thanks for watching, everyone, and please give us a like and a sub, especially if you're new here. I'm trying to get the channel to grow, and your help would be greatly appreciated. All right, take care, everybody, and I'll see you soon.